Hi everyone, welcome. Today we're going to be talking about how we can govern AI agents, do that at scale while controlling access and identity to the data that underpins those agents. I'm your host, Dominic Wellington. I'm Director of Product Marketing for Data and AI at SnapLogic, and I'll be joined later on by my colleague Matt Sager, who is a Principal Solutions Engineer at SnapLogic. So let's get started. Why are we talking about agents? Well, it's because everyone is talking about agents, right? Agents are emerging everywhere. Every single platform that you're using today is quickly adding AI and agentic capabilities. But because every single platform is adding these capabilities, there's not going to be a single platform where all the agents live. Instead, it's going to be the other way around. Every platform is going to have its own agentic AI capabilities. And the question is how we can manage and control and govern these new exciting capabilities. And the reason this is important is because many of the initial attempts at rolling out AI capabilities are failing. Depending on exactly who you ask, you'll get different numbers. But for instance, Forrester tells us that only 15% of AI projects scale successfully from a cool demo or a promising proof of concepts to something that can actually go into production and deliver real concrete benefits to users. And the challenge there is not intelligence. This is not something that can be fixed with a better model or more training or more data. The challenge is operationalizing those AI capabilities inside your environment and your enterprise workflows, connecting them up to the specific data that is going to provide context that is unique to where you are. Now, we spoke a little bit about this particular issue during Agent Fest. You may remember someone who looked a lot like me talking about how you can connect these agents up to your data and your systems. But today, we wanted to drill into one of the aspects that was on that screen, the AI gateway, and specifically the trusted identity, and talk about what that means in a little bit more detail. So to take a step back, the reason this is difficult is that systems are not well connected today. We have applications that we use to run our businesses. We have data that is stored in various different locations. We have workflows that more or less connect things up, and we try to apply governance across all of it. But it's all difficult because everything is disconnected, everything is siloed, and nothing is talking properly to everything else. In order to succeed with AI, we need a strong integration platform that can bring all of those elements together and expose a unified surface, both for AI agents to make use of, and for us to be able to govern and control what they're doing with that environment. That is the strong execution foundation that is required for success for AI agents and for really all of the other participants in enterprise workflows, whether they're human or they're AI. Integration is how all of these different participants are able to work, to execute, to deliver value. If we think about how this manifests in practice, users interact at the surface, what we might call the systems of engagement. So they're operating in their Slack, their Microsoft Teams, their web app, or whatever it might be. And what they need to get access to is data that is held in the systems of record. These are all of the many different commercial and homegrown systems and data repositories that you use to run your business today. The trick is how we connect those two levels up, how we can expose that information in a manner that is safe, that is controlled, that is compliant to the users so that they can do their jobs. So systems of execution, the middleware, are what we put in place to deliver that integration, the integration pipelines, and they can deliver that trusted execution with governance, with security and observability. And now we're adding systems of intelligence into that mix as well to deliver the agentic reasoning. So in this new model, users can operate together with an agent that can understand a conversational request and that can format a response into that same conversation, but they have structured and controlled access to the data underpinning that request via the system of execution, which is SnapLogic, which is the integration pipeline. And having that single view gives us the opportunity to apply policies across all of that communication, all of that integration. Now, each layer has very different responsibilities. The systems of engagement are the ones that have to take care of interacting with users. So they have to meet users where they are. One of the failure modes of new projects, new products, new initiatives in IT is forcing users to do something new, to go somewhere new in order to access new capabilities. Instead, we should be bringing the functionality to the users where they already are. But these systems are not designed to parse the intent or to reason over what the users give them. That's not their role. Their role is just as the interface. The systems of intelligence, that's where these AI capabilities come in, because they have the ability to handle ambiguity, to reason over what the users are asking for, to converse with them, to clarify what is being asked, or to then supply responses and context. But large language models, the current generation of Gen AI, is not good at deterministic rules. That's not what they're for. So when we need to apply policy, a fixed deterministic logic, that is one layer further, the system of execution, which can apply those rules, those policies, those controls, can enforce auditability and unlock access to the data. And they can do that because they're not trying to understand natural language or make reasoning calls. That's being handled at the level of the systems of intelligence. And finally, these different layers are all in service of protecting and abstracting the systems of record. They are good at storing and serving data and doing so at scale. And because of this abstraction, they don't need to know about any of the other layers that we just discussed about how the information is presented or consumed. That is handled at the appropriate layers of the stack. So what does that look like in practice? Well, let's talk about a customer of ours. This is Bison Transport. They had realized that they wanted to start rolling out new AI capabilities. They wanted to take advantage of these new technologies in order to better serve their users and their customers. But they also realized that they didn't want to fall into that trap of having the new shiny AI product fail because of lack of access to their internal systems. So first, they had to put in place the foundation to enable their AI ambitions. So 2026 is going to be their year of AI focus because they've put that solid foundation in place with 6 times faster deployment of data pipelines, unified data access across all of the different systems that they need to do their business, and their new transportation management system launched on schedule and with no downtime. And those of you who've been around IT for long enough will recognize that those are two things that do not often go together. So we're all very proud of that particular success. Now, starting to get into a little bit more detail, how do AI agents talk to the world? So there's the protocol, the Model Context Protocol, that was initially launched by Anthropic. It's now an open source standard. And this is how you can expose tools, resources, and prompts to the AI agents and to the LLMs. So SnapLogic implements the Model Context Protocol, so you can run an MCP client and access external tools via the MCP servers, or you can operate an MCP server in a pipeline to expose your systems of record as tools that other agents can take advantage of and have access to. The question is precisely about that access. How can we control that? How can we govern it? How can we apply policies? Because as the old joke goes, the S in MCP stands for security. So let's talk about how we can bring trusted agent identity to MCP, to agentic communications, and to all of these new exciting capabilities. So we're going to be talking about how we can propagate access tokens from the user to the agent to the backend system that holds the data, and maintaining that zero trust identity end to end throughout the whole chain. So this is where I'm going to hand over to my colleague Matt Sager, who's going to go into more detail and then show us a demo of how that works in practice. Over to you, Matt.
Thank you, Dominic. Before we talk about what SnapLogic does, let's establish what enterprises actually need. These 6 properties are what zero trust, which is the concept of verification at every step, looks like in an agentic context. And most organizations have none of them today. With verification at every level, the instinct is to put a gate at the front door and trust everything behind it. That is not zero trust. That's just a perimeter. Zero trust means the app is verified, the user is verified, the tool is verified, and the data endpoint is verified, each one independently every time. With provenance, you need a complete tamper-evident record of every data access, not just that a tool was called, but which agent called it, on whose behalf, and why. Without this chain of trust, you cannot do compliance, you cannot do audits, and you can't answer to regulators. The next 3, non-repudiation, downscoping, and short token burn rate, are where SnapLogic acts as the agentic security orchestration layer, enforcing properties that no one individual tool, agent, or developer needs to implement themselves. Non-repudiation, the IDP signed token that SnapLogic propagates through every hop is the cryptographic proof, binding user, app, and scope to every action automatically. With downscoping, SnapLogic performs the token exchange per the RFC 8693 for each tool. So every tool receives only the privilege that operation requires. And along with that is the short token burn rate. Tokens live for minutes at the MCP server layer, but they should only live at seconds at the tool layer. Least privilege at the data layer. In this architecture, the boundary is enforced by the token itself. A payroll token is invalid at the CRM endpoint, and the tool couldn't go sideways even if it wanted to. So these 6 properties are the requirements. And the question is how to actually build a system that delivers all of them at scale for every agent, every tool, and every request. Most teams are not being reckless with respect to security. They're using patterns that just simply were not designed for autonomous AI agents acting on behalf of humans. No IDP in the loop, no signed token, no user context. The agent acts as itself with broad access and no proof of who authorized it. With the bearer token being passed through unchanged, the IDP has issued a token for one context, and it gets carried into a completely different one. The scope never narrows. One compromise means full access everywhere. The IDP's identity context never propagates beyond the first hop. Tools downstream have no idea which human the request ultimately serves. And a valid token isn't enough if any app can present one. Without an MTLS, you're trusting the credential, not the verified machine the IDP issued it to. And with non-repudiation, which is the quote, AI did it problem, without a signed IDP token bound to every action, there's no cryptographic proof of who authorized what. Accountability is undefined. Let's walk through how trusted agent identity works in practice. Starting at the very beginning of the chain, the moment a human sends a prompt. With the user, a human sends a prompt, and this is the action that everything downstream needs. The LLM reasons and selects a tool, but it doesn't grant access. It carries an authorization token that it was given and nothing more. The MCP server receives the call and holds it. Nothing is executed in the token until the token is validated and scoped in the steps that follow. What this establishes is that the token travels with the request from the very first hop. The LLM itself cannot escalate, forge, or bypass it. So the bottom line is that the LLM is a participant in this chain, not an authority in it. The next steps are what give the token its meaning. Let's walk through the first thing that the token encounters, which is the entry gate. Here, there are two policies that must both pass before SnapLogic will do anything. The inbound TLS policy verifies the machine. Only the registered application with a valid client certificate gets through that door. The JWT validate policy verifies the human. The IDP signed token proves who the user is, and SnapLogic inspects every claim before anything proceeds. Two factors at the gate simultaneously. This is where the no identity thread and the no MTLS problems from the previous slide get closed out. The engagement app and the LLM can only reach SnapLogic if both policies pass. No tool or data have been touched yet, but the trust has already been established. Now that we know who the machine is and who the user is, the next step is turning that into a token the rest of the chain can rely upon. Now that the machine and the user are both verified, SnapLogic takes that proven identity and does something critical. It exchanges the initial token for a new one that the rest of the chain can actually use. With token exchange, per the RFC 8693, SnapLogic presents the verified identity from the previous step to the IDP and requests a new token with narrower scope, shorter time to live, and with the user's identity, and it adds the actor, that is to say, the calling tool embedded as provenance. This results in the IDP minting a new token for one specific tool and one specific operation. The previous bearer token is now closed out right here. Every tool invocation goes through this exchange. No tool ever receives the broad token, only the one IDP that the IDP issued specifically for it. Now let's see what the token actually delivers when it reaches the tool. The new token doesn't sit still. SnapLogic propagates it automatically to every tool in the chain, each one receiving exactly what it needs and nothing more. Each tool gets exactly the token it needs, no more, no less, and it expires in seconds. The human who sent the prompt is cryptographically tied to every tool call, every data access, all the way to the secure resource. That's trusted agent identity. Policies at the gate, token propagation through every hop, and the IDP as the proof authority at every step. Let's take a look. At the core of SnapLogic's trusted identity, trusted agent identity, is the policy configuration. And this is where SnapLogic's ease of use becomes a real differentiator. Each policy is configured through a simple UI in minutes, abstracting away the coding that would normally be required to implement a zero trust design from scratch. What you're looking at here is the policy configuration for the MCP server. it maps directly to the steps we just walked through. The inbound TLS policy verifies the calling machine. The JWT validate policy confirms the user identity. Authorized by role ensures that the user is permitted to proceed. And finally, the token exchange policy is what triggers the token to be exchanged before the MCP server executes anything. 4 policies, point and click, zero trust enforced end to end. To go a bit deeper on how these are configured, let's just take a quick look at the token exchange policy. Configuration is straightforward. Here, you see an example token exchange policy. In SnapLogic's visual design paradigm, it is point and click, no code required. That's the broader promise of SnapLogic as a low-code, no-code agentic integration platform. You get faster time to value without trading away security, quality, or performance. Enterprise-grade zero trust without the enterprise-grade implementation burden. Let's take a look at this in action. So in this demonstration, as you can see, I have a very simple application, the SnapLogic Financial Assistant. I'm using Okta as my IDP, and I have 2 separate users. One is an analyst, she's a lower level person, and one is a manager, a higher level person. So what that implies is that each of these have different sets of permissions based on their role, based on their attributes. So let's take a look first, logging in as Jamie Lee, the analyst. First thing that happens in my app is it redirects to Okta, and I'll enter in my Okta credential. And now I'm in the app, and I can see I'm Jamie Lee, and my token and everything is ticking away. I have a very long-lived token here. And I'm not going to go through all of these, but I'll start with this one, which says summarize the accounts by estimated value. Well, in my account system, there are some fields in here, one of which is estimated value, that this user, Jamie Lee, is not entitled to see based on her role. So if I send this in as a request, you see that it's going to query the tools. So behind the scenes, there's a connection to the SnapLogic MCP server. The MCP server is going to respond with all of the tools available. And then autonomously, the LLM, in my case, I'm using Claude, the LLM will then choose which tool is needed to answer this question and comes back with data. But if you notice here, even the LLM itself is saying, however, I noticed that the data doesn't include a clear estimated value field. So the LLM is looking at the available fields and giving her a best answer. If I now switch to Sam and ask the exact same question, Sam is the manager, and the manager has access to all of the estimated value data, and I send this in, you'll see much more granular data being returned. This is because Sam's identity and his claims are all propagated through all the way to the endpoint. And we have very specific data about each account. AM distributors, 25 million. Express logistics, 8 million, and so on. All of those data elements are returned because Sam has access to that, and they weren't returned for Jamie because she did not. It's that simple. One more example with a full token exchange. I'm going to say summarize the payroll data. And in this example, same thing is going to happen. It's going to query the tool and ask for the payroll data. Sam is a manager, so he is entitled to see the payroll data. As you can see, we get very detailed payroll data. Now, if I were to log back in, which I'm not going to do as Jamie, she would not see any of this. However, one thing that's really important is that behind the scenes, the token was exchanged, and it was exchanged for a downscoped token and a token that included the specific calling app. So if I grab that token through the magic of software, I have that actual token, and I go into Postman and I try to call from Postman that exact same endpoint here. I'm going to pop in my token, same token, the original token that hadn't been exchanged, and I try to make that call to that same endpoint, I'll get an error. And the error is a 403, I'm forbidden. And the reason why is because the direct user access is prohibited from this endpoint. So here, we've added in my application the specific endpoint that was a valid endpoint for which this tool could be, from which this tool could be called. In this example in Postman, because it's not a valid endpoint, I get that 403, even though I'm entitled to see that data as Sam, the manager. The other thing to note here is this gives you that non-repudiation in the form of very granular audit controls. So all of this data is now auditable, so you can see who did what at any point in time. So if there's any bad actors out there or anything that shouldn't have happened, you have a way to get to the exact history of all of that. And with that, I'm going to turn it back to Dominic to wrap this up.
Excellent. Thank you, Matt. So what we've seen is how we can secure the agentic enterprise, how we can gain access to these new powerful capabilities that agentic AI brings us, but in a way that is secure, that is governed, that gives us access to the systems and the data that the business runs on without anyone getting in trouble. And the reason for that is because you have this AI gateway with trusted agent identity in the connection along the MCP path. The token propagation is the engine that automatically delivers that provenance of where the requests for access are coming from. It enforces the non-repudiation that Matt talked about, and it executes the downscoping, and it does all of that securely and at scale. And every action is documented, it is traced for explainability, for observability, and for compliance after the fact. So you can go back and look at the logs and you can see what actions an agent took and on whose behalf it took those actions with what access credentials. So with that, thank you for attending. We hope that you found this demonstration interesting and that it gave you some ideas for how we could work with you in your environment to add agentic AI capabilities on the data, the apps, and the systems that you're using to run your business today, and that it gave you some ideas for what that could enable. We would love to hear from you and explore those possibilities together, so please do get in touch. But until then, thanks once again, and we look forward to talking again soon.